Behind the sun, something is doing what comets should never do, ejecting material toward our star, not away from it. Picture this. It's deep night in the Chilean Andes. 3,000 meters above sea level, where the air is thin and the stars burn with an intensity that makes you feel small. An automated telescope clicks through its programmed sequence, capturing frame after frame of the southern sky. Its algorithm is searching for motion for objects that shift position against the fixed background of distant stars. On July 1st, 2025, it found something, a fuzzy dot, unremarkable at first glance. Just another piece of cosmic debris in a universe full of wandering rocks. But within 48 hours, as more observatories turned their attention toward this newcomer, astronomers realized they were looking at something extraordinary. The object wasn't from our solar system. The mathematics of its trajectory told a story written in velocity and angle, in gravitational curves that couldn't be denied. It had traveled from somewhere near the galactic core from the direction of Sagittarius, that dense band of stars marking our view toward the Milky Way's ancient heart. And it was moving fast. 58 kilometers per second relative to the sun. To put that in perspective, that's twice the velocity needed to escape the sun's gravity forever. That's the speed of something that has been falling through the galaxy for millions, perhaps billions of years, gathering momentum from ancient stellar encounters we can only imagine. They designated it 3I Atlas, the third confirmed interstellar object to ever enter our solar system. But 3I Atlas is different, profoundly different. It's ejecting a continuous stream of gas directly toward the sun, not away from it, as every comet should. Its chemistry is wrong, abundant nickel with virtually no iron, a ratio that shouldn't exist in nature, and its trajectory nearly perfectly aligned with Earth's orbital plane, a statistical improbability that occurs randomly in perhaps 1 out of every 500 interstellar visitors. Here's what makes this truly unsettling. On October 29, 2025, 3I Atlas will reach perihelion, its closest point to the sun. On that exact date, Earth will be positioned on the opposite side of our star. Every telescope on our planet will have the sun directly between us and the comet. Solar conjunction. Complete observational blackout during what should be the object's most active and revealing moment. The timing is either the universe's most convenient coincidence or something else entirely. Tonight we'll explore what 3I Atlas might be, where it came from, and what it could want with our sun. We'll examine the verified data, the troubling silences, and the questions that keep astronomers awake long after their telescopes have closed for the night. What you're about to hear will challenge comfortable assumptions. Some of it is established science. Some of it is careful speculation. All of it is worth considering, because in a few weeks, we'll know. December will bring answers, the trajectory will be measured, and we'll discover whether we're looking at the most unusual natural comet ever recorded, or something that requires us to completely rethink our place in the cosmos. The countdown has begun. Let's begin at the beginning. Let's start with certainty, with data, with the things we can measure and verify beyond reasonable doubt. On the night of July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, for short, captured images of a new object during its automated survey of the southern sky. The observatory sits high in the Chilean Andes, part of a global network designed to detect potentially hazardous asteroids before they become problems for Earth. But this wasn't an asteroid. The initial designation was C2024L4, just another catalog entry in humanity's growing list of cosmic debris. But within 2 days, as more observations accumulated, the orbital calculations revealed something remarkable. The object's velocity relative to the sun was approximately 58 kilometers per second. That's more than twice the solar system's escape velocity at Earth's distance. Think of it this way. Throw a ball upward. It rises, slows, and falls back. But throw it fast enough, 11 kilometers per second from Earth's surface, and it escapes gravity entirely, never returning. Our sun's gravitational grip at Earth's orbital distance requires just over 42 kilometers per second to overcome. 3I Atlas was traveling at 58. That speed combined with the trajectory's hyperbolic shape meant only one thing. This object couldn't have originated in our solar system. It had come from beyond, from interstellar space, from somewhere orbiting another star, perhaps hundreds of light years away, ejected millions or billions of years ago and wandering the galactic void ever since. It was coming from the direction of Sagittarius, from somewhere near the densest star fields of the Milky Way's center. Whether it originated there or merely passed through is unknown. At interstellar distances and timescales, even fast-moving objects lose their connection to birthplace. The galaxy's gravity well, the subtle perturbations from passing stars, the long dance of orbital mechanics over eons, all work to erase origin stories. What we know is where it is now, where it's going, and that makes it the third confirmed interstellar visitor in human history. The first was Oumuamua in October 2017, small, dark, cigar-shaped, tumbling through the inner solar system at high speed. It exhibited slight, non-gravitational acceleration, a push that couldn't be explained purely by the sun's gravity. The natural explanation was outgassing like a comet, though no visible coma appeared. Harvard's Avi Loeb proposed an alternative, a light sail, an artificial structure pushed by solar radiation pressure. The scientific community largely rejected that interpretation, favoring natural explanations, even if they required unusual conditions. The second was 2I Borisov in August 2019, a clear comet behaving exactly as expected. Coma-tail spectroscopic signatures matching solar system comets almost perfectly. Nothing unusual. A cosmic tourist that came and left, confirming that interstellar objects could be exactly what they appeared: natural debris from planet formation processes ejected into the galactic void. Now 3I Atlas, different from both predecessors. Early observations showed it had a coma, a cloud of gas and dust typical of comets. Spectroscopic analysis revealed it was releasing carbon dioxide cyanide traces of water vapor, all normal cometary materials. But the proportions were deeply unusual. The ratio of carbon dioxide to water was 8:1, among the highest ever recorded. Most comets are water-rich remnants of the outer solar system's icy reservoirs. 3I Atlas is CO2 dominant, suggesting formation in a very different environment. And then there was its trajectory. Objects approaching from interstellar space can arrive from any direction at any angle. The galaxy is three-dimensional and there's no preferred geometry. Most interstellar visitors should have highly inclined orbits coming in from above or below the relatively flat plane where Earth and the other planets orbit. But 3I Atlas arrived with an orbital inclination of just 4.89 degrees from the ecliptic plane, almost perfectly aligned with Earth's orbit. Almost as if it understood our geometry, the statistical probability of that alignment, given a random trajectory from interstellar space, is approximately 0.2%. That's 1 in 500. Not impossible. Not evidence of anything artificial, but rare enough to notice. And it wasn't just the ecliptic alignment. The object's path brought it unusually close to multiple planets. Mars in early October, Venus later in its trajectory. Jupiter's gravitational influence detectable in its orbital evolution. Close encounters with three major planets shouldn't happen together. The probability of that combination given a random interstellar trajectory is approximately 1 in 20,000. Avi Loeb calculated these probabilities carefully. He published papers. He pointed out the statistical anomalies, and he suggested cautiously and academically that the trajectory might not be random, that it might be designed. NASA's response was swift and dismissive. Tom Statler, program scientist for near-Earth object observations, called the suggestion absolute nonsense. Other astronomers agreed. The scientific consensus held firm: 3I Atlas is a comet. An unusual one, certainly, with some properties that challenge current models. but a natural object nonetheless, and they had good reasons for that position. 3I's Atlas does look like a comet. It exhibits comet behavior. It has all the characteristics we associate with icy debris from the outer reaches of planetary systems. The coma, the outgassing the tail that developed by late August. All textbook. But there were other details. Smaller things, things that individually could be explained away but together painted a picture of something not entirely understood. The size estimates kept changing. Initial observations suggested it might be 20 kilometers across, massive for an interstellar visitor. Subsequent refinements brought that down to 10 kilometers. Then, Hubble Space Telescope data analyzing light curves and brightness suggested a nucleus closer to 5.6 kilometers in diameter. But here's the puzzle. When scientists calculated the object's mass derived from tracking how it resisted being pushed around by its own gas jets, they arrived at a figure of at least 33 billion tons. That's heavy. Perhaps too heavy for a 5.6 kilometer chunk of ice and rock with the density we'd expect from cometary material. Unless the object isn't solid, unless there's empty space inside, unless the structure is more complex than a simple icy rubble pile. And then there was the timing of perihelion, the moment when 3I Atlas would swing closest to the sun, experiencing maximum solar heating, maximum activity, potentially revealing its true nature through spectroscopic analysis of peak outgassing. October 29, 2025. On that date, Earth would be on the exact opposite side of the sun. Every telescope on our planet, every observatory in every nation would have the sun directly between us and the comet. We would be in solar conjunction, observationally blind at the most critical moment. Loeb pointed out something significant about this timing. If you wanted to make a major change to your orbit, if you wanted to slow down and capture yourself into a bound orbit around the sun rather than continuing on to interstellar space, perihelion is when you do it. It's called the Oberth effect, and it's fundamental to orbital mechanics. A little bit of thrust applied, when you're moving fastest, when you're closest to a massive body, produces the maximum change in trajectory. You could use the sun's gravity and a well-timed engine burn to brake from interstellar speed, to transition from visitor to resident, to stay instead of leaving. And if you wanted to make that maneuver without being observed, October 29th would be the perfect window, hidden from Earth's view, doing something we couldn't see. This is where speculation begins to creep into verified data, where pattern recognition might be seeing design instead of chance. We'll return to these questions later with appropriate caution and multiple competing explanations. For now, here's what we know with certainty. 3I Atlas exists. It came from beyond our solar system. It's moving through our neighborhood right now, following a trajectory governed by gravity and perhaps by forces we haven't yet detected. It will reach perihelion on October 29th, and when it does, we won't be watching. December will tell us what happened during those blind days behind the sun. December will tell us whether 3I Atlas continued on its journey or whether something unprecedented occurred. December is when we'll know. Now we move into territory where observations challenge expectations, where the data doesn't quite fit the models, where questions begin. Let's talk about chemistry. Comets are cosmic time capsules, frozen relics from the early solar system, preserving the composition of the primordial disk from which planets formed 4.5 billion years ago. When we analyze their spectroscopic signatures, the fingerprints of light they reflect and emit, we're reading chemical histories stretching back to our system's birth. Most comets are water-rich. They contain frozen H2O mixed with other volatile compounds: carbon monoxide, carbon dioxide, methane, ammonia. The ratios vary, but water typically dominates. It's the primary constituent, the foundational ice that binds everything else. 3I Atlas is different. Spectroscopic observations from multiple telescopes, including the Very Large Telescope in Chile and various ground-based observatories, consistently show a carbon dioxide to water ratio of approximately 8:1. That means for every molecule of water released, 8 molecules of CO2 escape. Among the highest ratios ever recorded in any comet, local or interstellar. Why does this matter? Because it suggests formation in an environment very different from our outer solar system. CO2-rich comets are rare but not unknown. They typically form in the coldest, most distant regions where carbon dioxide can condense more easily than water. But even in those environments, we don't usually see ratios this extreme. One explanation, 3I Atlas formed around a star with a different chemical abundance than our Sun. Perhaps its parent system had more carbon relative to oxygen. Perhaps unusual stellar evolution produced different conditions in its primordial disk. We're only beginning to understand the diversity of planetary systems, and exoplanetary chemistry might differ dramatically from what we consider normal. But then there's the nickel. On August 21, 2025, astronomers using the Very Large Telescope detected nickel in 3I Atlas's coma, not trace amounts, approximately 100 kilograms per second of gaseous nickel being released into space. Nickel in comets isn't unprecedented. Most cometary material contains metals in small quantities locked in dust grains and released during outgassing. But nickel and iron are cosmic twins. They form together in supernova explosions. They travel together through interstellar space. They appear together in comets, asteroids, and planetary bodies throughout the known universe. Finding abundant nickel should mean finding abundant iron. 3I Atlas shows almost no iron signature. The spectroscopic lines that would indicate iron emission are essentially absent. It's releasing nickel without its inevitable companion. The published paper from the VLT team explicitly noted this anomaly. They acknowledged it couldn't be easily explained through standard cometary chemistry. One researcher described it as like finding smoke without fire, possible perhaps under extremely unusual conditions, but requiring explanations that stretch our understanding of natural processes. A few theories have been proposed. Perhaps the object formed in a stellar environment where nucleosynthesis processes favored certain isotopes over others. Perhaps it's a fragment from a planet with unusual core composition where differentiation concentrated nickel at the surface while sequestering iron deeper. Perhaps we're seeing evidence of exotic chemistry from an alien world's formation, something our local experience hasn't prepared us to recognize. All plausible, all natural, all requiring conditions we haven't directly observed but can imagine existing somewhere in the galaxy's vast diversity of stellar systems. And then there's the thermal paradox. Comets brighten as they approach the sun. The increasing solar radiation heats their surfaces, causing volatiles to sublimate, transitioning directly from solid ice to gas without passing through liquid phase. This outgassing creates the coma and tail. The closer to the sun, the more active the comet becomes. Activity correlates with temperature. More outgassing means more heating. It's straightforward thermodynamics, but 3I Atlas is releasing massive amounts of material while remaining colder than it should be given its distance from the sun and the intensity of solar radiation hitting its surface. Infrared observations show surface temperatures inconsistent with the observed outgassing rate. One observer compared it to watching someone sweat profusely in a freezer. The physics don't match the observation. Again, explanations exist. Perhaps the object's structure is unusual, a porous rubble pile with internal cavities that allow heat to dissipate rapidly. Perhaps the composition includes materials with unexpected thermal properties. Perhaps the rotation rate or axis orientation affects how heat distributes across the surface. Or perhaps something else is happening, something we haven't considered because we've never encountered it before. These chemical and thermal anomalies aren't smoking guns. They're not definitive evidence of anything artificial or unprecedented. Nature is endlessly creative, producing extremes and outliers that challenge our categorization systems. The universe doesn't consult our models before deciding what's possible. but the anomalies accumulate. CO2 dominance, nickel without iron, thermal contradictions, each individually explainable. Together, they create a pattern of strangeness that makes 3I Atlas more than just another interstellar comet passing through. They make it a question mark, and questions demand answers. So we keep watching, we keep measuring. We wait for December when the object emerges from behind the sun and we can observe it again with our most powerful instruments. Wait to see whether post-perihelion observations confirm natural processes or deepen the mystery further. The chemistry of 3I Atlas tells us it came from somewhere very different from here. Whether that difference is merely cosmic geography formation around a different star or something more profound remains to be determined. For now, we acknowledge the anomalies, we note the discomfort they create in our standard models, and we remember that the universe has surprised us before. It will surprise us again. Statistics can be deceptive. Small probabilities happen all the time if you wait long enough or observe enough events. Flip a coin 10 times and getting 10 heads is unlikely but not impossible. The universe doesn't conspire. It just expresses probability, but sometimes the numbers become difficult to dismiss. Let's examine the geometry of 3I Atlas's trajectory, not with preconception or agenda, but with careful attention to what the data actually shows. First, the orbital inclination, the angle between the object's path and Earth's orbital plane known as the ecliptic. For an object arriving from random interstellar space, this angle should be randomly distributed. The galaxy is three-dimensional stars above, below, and all around us. There's no preferred direction, no cosmic orientation that would favor arrivals aligned with our local geometry. Imagine throwing darts at a sphere from random positions. Some will hit near the equator, but most will strike at various angles distributed evenly across the entire surface. That's what we should see with interstellar objects' trajectories coming in from every conceivable angle. Anything from 0 to 90 degrees is equally probable in a three-dimensional galaxy with no preferred direction. 3I Atlas has an inclination of 4.89 degrees, almost perfectly aligned with the flat disk where Earth and the other planets orbit the Sun. It's coming in nearly level with our planetary plane, as if it understands that this is where the interesting worlds are. As if it knows that habitable zone planets typically orbit in their star's equatorial plane, flattened by the same rotational dynamics that created the protoplanetary disk. What's the probability of that approximately 0.2% or 1 in 500? Let that sink in. Out of 500 random interstellar trajectories, only one would show this level of alignment by pure chance. Not impossible. Certainly not proof of intelligent design, but notable. The kind of number that makes statisticians pause and double-check their calculations. Now add the planetary encounters. 3I Atlas's path brought it within 29 million kilometers of Mars on October 3rd. In cosmic terms, that's practically a near miss. Close enough that the 7 spacecraft orbiting Mars could turn their instruments toward the visitor and capture observations at resolutions impossible from Earth. The trajectory also brings the object relatively close to Venus and within Jupiter's gravitational influence. 3 significant planetary encounters along a single interstellar passage. The probability of that combination occurring by chance is approximately 1 in 20,000. Think about what that means. If you randomly threw an object into the solar system from a random direction in interstellar space, you'd expect this particular pattern of close planetary encounters about once every 20,000 attempts. Not impossible, but deeply improbable. Avi Loeb, the Harvard astrophysicist who's become a controversial figure in this story, calculated these probabilities carefully. He published them in peer-reviewed papers. He didn't claim they proved artificial origin. He simply noted that the trajectory was statistically unusual and suggested it warranted serious investigation. The response from the astronomical community was largely dismissive. NASA officials called the suggestions absolute nonsense. Other scientists pointed out that with thousands or millions of interstellar objects passing through the galaxy, some will inevitably have unusual properties. Rare doesn't mean impossible. Improbable doesn't mean designed. And they're right. Statistics alone don't prove anything, but statistics plus chemistry plus timing create a pattern worth examining. Let's talk about that timing. About October 29th and what makes it so significant. Perihelion is the moment when an orbiting object reaches its closest point to the Sun. For 3I Atlas, that moment occurs on October 29, 2025, at a distance of 0.39 astronomical units inside Mercury's orbit, deep in the Sun's gravitational well, experiencing intense solar radiation. This is when comets become most active. Peak heating causes maximum outgassing. Spectroscopic observations during perihelion reveal compositional details invisible at greater distances. It's the ideal time to study an object's true nature. But on October 29th, Earth will be positioned on the exact opposite side of the Sun. We'll be in solar conjunction. The Sun will be directly between us and 3I Atlas, and its overwhelming brightness will make observation essentially impossible. Ground-based telescopes won't be able to see anything. Even space telescopes like Hubble and Webb, which aren't affected by daylight, will struggle to image anything that close to the solar disk. For 8 days, from approximately October 21st through October 29th and into early November, 3I Atlas will be observationally lost, hidden behind the Sun's glare, doing whatever it does during perihelion without human witnesses. Here's where things get interesting from an orbital mechanics perspective. If you wanted to change your trajectory significantly, if you wanted to slow down and capture yourself into a bound orbit around the Sun instead of continuing on an escape trajectory, perihelion is exactly when you do it. It's called the Oberth effect, and it's fundamental to spaceflight. The principle is simple: thrust applied when you're moving fastest produces the greatest change in kinetic energy. If you fire your engines at perihelion when you're at maximum velocity, deep in the Sun's gravity, well, you get more bang for your buck than firing at any other point in your orbit. Every deep space probe we've sent, Pioneer, Voyager, Cassini, New Horizons, uses gravitational assists and Oberth maneuvers to reach their destinations efficiently. You speed up by firing engines at perihelion, but the effect works in reverse too. You can brake. You can deliberately reduce your velocity at perihelion and let gravity capture you into a bound orbit instead of an escape trajectory. This is called a reverse Oberth maneuver, and it's exactly what you'd do if you wanted to transition from passing through a star system to staying in it permanently. The math is straightforward. 3I Atlas is currently traveling at approximately 67 kilometers per second relative to the Sun on its inbound trajectory. To capture into a stable elliptical orbit that remains gravitationally bound, it would need to reduce that velocity to below solar escape velocity, approximately 42 kilometers per second at perihelion distance. A delta V change of about 25 kilometers per second. Significant but not impossible for a spacecraft with appropriate propulsion. And if you were planning to make such a maneuver, October 29th would be the optimal time. Not just because of orbital mechanics, but because Earth, the planet with the most advanced telescopes, the most interest in tracking you, the only civilization capable of analyzing what you're doing, would be on the far side of the Sun. Unable to observe. Hidden from view. Is this intentional? Is the timing deliberate? Or is it simply geometric coincidence, the way orbits happen to align when you calculate the trajectory from a given starting point? The question can't be answered from current data. We don't know enough about 3I Atlas's origin, its velocity history, whether anything about its trajectory has been adjusted during its millions of years traveling through interstellar space. What we can say is this: the probability of arriving at perihelion precisely when Earth is in solar conjunction is low. Not infinitesimally low, but perhaps 1 in 20 to 1 in 30, depending on how you calculate arrival time windows. Just another improbable thing stacked on top of all the other improbable things. Individually, each anomaly can be explained. Collectively, they create a picture that makes some scientists deeply uncomfortable and makes others wonder if we're seeing patterns that exist only in human tendency toward pattern recognition. Statistics don't prove intention, but they do raise questions. And this October 29th Behind the Sun, where we cannot watch those questions, will either be answered or deepened. We'll discover the truth in December. Now we enter territory where facts become frustratingly sparse and interpretation becomes necessary, where the story is as much about what we don't know as what we do, where absence of information creates space for speculation to grow. Let's talk about October 2025, about missing data and convenient silences. On October 1st, the United States government entered a partial shutdown. Budget negotiations in Congress had failed to reach compromise, triggering automatic furloughs across federal agencies. NASA, along with numerous other departments, ceased most operations. Over 15,000 NASA employees were temporarily sent home. The agency's website stopped updating. Public communications went silent. Press releases halted. The usual flow of space science information from Mars rover images to deep space observations dried up overnight. Bureaucratic paralysis at the worst possible moment. Because 2 days later, on October 3rd, 3I Atlas made its closest approach to Mars, sweeping past at 29 million kilometers, close enough for unprecedented observation by the 7 spacecraft orbiting the red planet. NASA's Mars Reconnaissance Orbiter has an instrument called HiRISE, the High Resolution Imaging Science Experiment. It's designed to photograph the Martian surface from orbit with enough detail to see individual boulders and rover tracks. When pointed at 3I Atlas from 29 million kilometers away, it should have been able to resolve features down to about 30 kilometers across. Not enough to see surface details on a 5.6-kilometer nucleus, but enough to separate the solid core from the surrounding coma of gas and dust. Enough to get a real size estimate. Enough to observe structure and shape. Enough to potentially see whether anything about the object was geometrically regular in ways that natural rock and ice shouldn't be. HiRISE was operational. The Mars Reconnaissance Orbiter continued its normal functions throughout the government shutdown. Other rovers and orbiters kept transmitting data. Perseverance uploaded raw images to public servers throughout the entire period. So why were the HiRISE images of 3I Atlas never released? The official explanation: government shutdown meant no staff available to process requests or prepare data releases. Fair enough. Government paralysis does create delays, but here's what strains that explanation. ESA, the European Space Agency, completely unaffected by American politics, also failed to produce useful images from their Mars observations. ESA released their photographs on October 7th, 4 days after the flyby. What they showed was disappointing fuzzy white dots moving against a star field. No detail, no structure. Images that told us essentially nothing we didn't already know. Their explanation was technical. The cameras on Mars orbiters are designed to photograph the planet's surface from a few hundred kilometers away. They're optimized for targets that are bright nearby and sunlit. 3I Atlas was 10,000 to 100,000 times fainter than their usual subjects. They did their best with inadequate equipment. Plausible, reasonable, consistent with engineering limitations. But NASA's HiRISE was specifically designed for long-range high-resolution imaging. Its angular resolution at 29 million kilometers would have been more than 10 times better than anything ESA achieved. If any instrument could reveal 3I Atlas's true nature, it was HiRISE. And we still don't have those images. More than a month later, they remain unreleased. Stuck in processing pipelines awaiting review, lost in bureaucratic systems disrupted by the shutdown, or being withheld deliberately until proper analysis and verification can occur. We don't know which. And then there's China. The Tianwen-1 mission orbiting Mars since 2021 has cameras and spectrometers fully capable of contributing observations during the October 3rd flyby. The spacecraft was positioned appropriately. The timing was perfect. China has released nothing. No images, no spectroscopic data, no public statement about whether they even attempted observations. Complete silence from a space program that typically shares significant discoveries as part of international scientific cooperation. The UAE's Hope orbiter, equipped with excellent spectroscopic instruments ideal for analyzing cometary composition at relatively close range, also released nothing. No data, no preliminary findings, no acknowledgement that observations occurred. Multiple sovereign governments with completely separate bureaucracies and priorities, different political systems, different decision-making processes, different incentives for information sharing, all simultaneously unable or unwilling to share their best data on the most scientifically significant object to visit our solar system in years. The pattern is difficult to ignore, and it becomes harder to attribute to mere coincidence when you examine what happened on social media platforms during the same period. Starting around October 7th, posts about 3i Atlas began disappearing from various platforms, not being flagged as misinformation, not being marked with warning labels, actually vanishing. A Reddit user documented posting a detailed thread analyzing chemical anomalies based on published spectroscopic data. The thread gained traction quickly, accumulating hundreds of upvotes and dozens of comments within 2 hours. Then it was gone. Deleted from existence, not removed with a moderator explanation, just erased. When the user tried to repost, the submission wouldn't go through. Shadow banned without notification or explanation. On Twitter now, several astronomy accounts reported significant engagement drops after October 7th. Posts that would normally reach tens of thousands of people suddenly plateaued at a few hundred views. No official restrictions, no warning messages, just algorithmic suppression. Quiet enough to be deniable but aggressive enough to be effective. YouTube presented a different problem. Content creators who posted analysis videos speculating about 3i Atlas began receiving demonetization notices. The stated reasons varied, discussing sensitive topics without proper context, potentially misleading content about scientific matters, or the vague but ominous content that may not be suitable for all advertisers. The pattern was clear. You could make a video saying, 3i Atlas is definitely just a comet, and mainstream science has it figured out. That was fine. Monetized, promoted by the algorithm. But suggest there might be anomalies worth investigating, and suddenly your video becomes advertiser unfriendly. Facebook's fact-checking system went into overdrive. Posts sharing information about trajectory anomalies were flagged as partly false, even when they quoted Avi Loeb's published calculations verbatim. Missing context warnings appeared on discussions of the Mars flyby. Articles offering reassurance. Space agencies confirm no threat from interstellar comet. Experts say unusual features, likely natural processes, were attached to nearly every post discussing the object. The timing was coordinated. All of this ramped up within 48 hours of the ESA photo release, right when public frustration peaked over the lack of quality images. Now, to be fair, social media platforms suppress content constantly. Algorithms change. Engagement fluctuates. Fact-checkers flag misinformation. These are normal platform operations, not evidence of coordinated censorship. Unless there's a pattern. Unless it's all happening at once. Unless it's targeting one specific topic at the moment when public interest is highest and official answers are most absent. Some content creators started using coded language to avoid suppression. Instead of 3i Atlas, they'd say the visitor or the object. Instead of artificial or extraterrestrial, they'd use non-terrestrial or anomalous. It was like watching people develop a new vocabulary to discuss something platforms didn't want discussed openly. The Streisand effect in real time. The more the content got suppressed, the more people assumed something was being hidden. The more aggressively fact-checkers pushed back, the less people trusted the official narrative. Every attempt to manage the conversation just amplified suspicion that the conversation needed managing. Here's what we know for certain data that should exist. High-rise images, ESA spectroscopy international observations has not been released. Social media platforms implemented aggressive content moderation focused specifically on 3I Atlas discussions during early October. Multiple governments went simultaneously quiet about observations made during the Mars flyby. We don't know why. Maybe it's exactly what it appears to be: bureaucratic delays, equipment limitations, normal platform moderation, and unfortunate timing. Maybe in December, when more data emerges, the missing pieces will fill in and reveal nothing sinister occurred. Or maybe the silence is deliberate. Maybe what was observed during the Mars flyby requires careful analysis before public announcement. Maybe institutional decision-makers concluded that uncertainty breeds speculation, and silence breeds less chaos than partial revelations would. We'll know soon enough. December is coming, and December brings clarity, whether institutions want it or not. Because this time, amateur astronomers are ready. This time, hundreds of independent observers will be watching with their own equipment, sharing data openly, determined to have verifications separate from official channels. This time, the silence won't hold. When institutions go silent, communities organize. When official channels close, informal networks open. This is one of the most interesting aspects of the 3I Atlas story. Not what space agencies did or didn't reveal, but what ordinary people accomplished with limited resources and boundless curiosity. Let's talk about the citizen scientists, the backyard astronomers, the amateur image analysts who refuse to simply wait for official announcements. On October 3rd, the same day as the Mars flyby, a Portuguese amateur astronomer operating under the username Dobsonian Power uploaded an image to Reddit. It showed 3I Atlas captured through his solar telescope equipment, not designed for deep space observation, optimized instead for safely viewing our sun. Solar telescopes use specialized filters to handle extreme brightness. They're not built for faint, fast-moving objects traveling millions of kilometers away. The image Dobsonian Power captured was fuzzy, grainy, pushed to the limits of what his equipment could resolve. But within that fuzz, he claimed to see something: structure, dark geometric shapes, angular protrusions, patterns that didn't match the typical diffuse glow of a comet's coma. His caption was simple: "What on earth is it?" Within 6 hours, the image had been shared across every major astronomy forum, subreddit, and social media platform. The reaction split immediately into two camps. One group saw clear evidence of artificial structures, proof that 3I Atlas was exactly what mainstream science refused to admit. The other group dismissed it as classic pareidolia, the human tendency to see patterns where none exist, amplified by inappropriate equipment and aggressive digital processing. The debunkers had solid technical arguments. Solar telescopes simply aren't designed for this kind of observation. Using them to photograph a faint object in deep space is like trying to read fine print through welder's goggles. Add aggressive digital enhancement to compensate for the inadequate setup, and you're essentially asking algorithms to invent details that aren't really there. But here's what made Dobsonian Power's image harder to dismiss than typical internet anomaly, claims the photographer himself. He's not some random conspiracy theorist with a cheap telescope and too much imagination. His YouTube channel features a decade of legitimate astrophotography work, careful documentation of equipment, methodology, image processing workflows, peer feedback from other amateur astronomers, standards and practices that demonstrate technical competence. This wasn't someone trying to manufacture evidence for clicks. This was an experienced observer who captured something unusual and honestly couldn't explain what he was seeing. When pressed about the anomalous structures, he didn't double down with wild claims. Instead, he acknowledged uncertainty. He explained his processing methods. He promised to try again when the object became visible from Earth in early November after passing behind the Sun. His response was measured scientific, appropriately cautious, which made the reaction to his image even more telling. Within 24 hours, multiple websites published articles specifically debunking his capture. Amateur telescope captures strange 3-eye atlas image. Here's why it's not what it seems. The timing felt coordinated. The tone felt defensive, as if someone needed to quickly establish the narrative that nothing unusual had been photographed before the image gained too much traction. And then the enhancement wars began. Users across Reddit, Twitter, and various forums started downloading the original ESA images from the Mars flyby and running them through their own processing algorithms. Some used standard astronomical image stacking techniques, combining multiple exposures to reduce noise and increase detail. Others employed AI upscaling tools designed for enhancing low-resolution photos. A few went full chaos mode with machine learning models trained to reconstruct fine details from limited data. The results varied wildly. Some enhanced images showed nothing but slightly sharper versions of the same fuzzy dot. Clean processing, honest methodology, disappointing but reliable results. Others revealed what appeared to be distinct geometric patterns, edges, structures that seemed too regular to be natural ice and rock. Enhancement after enhancement, showing similar features in roughly the same locations. And many in fact, were obviously fake. Digital art created by people with too much time and too much Photoshop skill. Images showing metallic surfaces, solar panels, antenna arrays, running lights, visible thrusters. Most were crude, instantly recognizable as hoaxes, but they served a purpose for those wanting to muddy the waters. The problem with aggressive image processing, especially using AI, is that you're no longer looking at what's actually there. You're looking at what an algorithm thinks should be there based on its training data. If you train an AI on thousands of images of spacecraft and then ask it to enhance a blurry dot, it might very well invent spacecraft-like details because that's what it learned to recognize. It's a scientific dead end wrapped in the illusion of clarity. But the proliferation of these enhanced images had an unintended effect. They created so much noise that distinguishing between legitimate amateur observations and outright fabrications became nearly impossible. Within 48 hours of the ESA release, dozens of supposedly enhanced versions circulated online. Some showed metallic surfaces. Others depicted what looked like solar panels. A few even included running lights and visible thrusters. Most were obviously fake. But mixed in with the noise were a handful of images that felt different, more subtle, less sensational. Images that showed just enough unusual regularity to make you wonder whether something real was being obscured by the flood of obvious hoaxes. And then, on October 4th, something else appeared. Something that would drive the speculation even deeper. An anonymous post on 4chan's paranormal board. The title, ESA Data Leak. Internet leaks are common. Most are easily dismissed as creative fiction or outright trolling. But this one was different. The level of technical detail was unsettling. The poster began with a credential claim. I am a doctoral researcher working with the European Space Agency with continuous access to the combined observational data of 3-eye atlas. Specific enough to sound legitimate, vague enough to maintain anonymity. What followed was a series of technical claims about observational anomalies that, if true, would fundamentally challenge our understanding of what 3-eye atlas actually is. First, spectroscopic analysis showing approximately 100 kilograms of nickel gas per second being released, but with almost no iron emission. This was the chemical impossibility we discussed earlier. Natural stellar chemistry makes nickel and iron inseparable. Finding one without the other violates basic cosmic processes. Second, thermal contradictions. The object releasing massive amounts of gas while remaining far colder than expected given its outgassing rate and proximity to solar radiation, like watching someone sweat profusely in a freezer. Third, trajectory precision. The path isn't just unusual, it's a perfect straight shot from the direction of the galactic core. No wobble, no deviation, no signs of gravitational perturbation during millions of years traveling through interstellar space, as if it was aimed. Then came the speculative leap. The poster suggested 3I Atlas fit the profile of what they called a post-biological entity, not a natural comet, not a conventional spacecraft, something in between. They described it as having a three-phase particle engine with estimated power output of 75 megawatts, continuously transmitting an active signal probing our solar system. The post concluded with a theoretical framework, the cue-ball hypothesis, an exotic construct from particle physics, a type of non-topological soliton that could theoretically exist at macroscopic scales, far larger than subatomic particles. If stable, a cue-ball could have properties that seem impossible under normal physics. It could be incredibly dense while appearing diffuse. It could absorb and redistribute energy instantaneously across its entire structure, explaining thermal contradictions. It could even explain the nickel without iron problem if its internal quantum state preferentially produces certain isotopes. Wild speculation, absolutely. But grounded in actual physics, however exotic and theoretical. Within 18 hours, the post had been screenshotted and shared across Reddit, Twitter, and dedicated UFO research forums. The conspiracy subreddit thread discussing it accumulated over 2,000 comments before moderators locked it for violating rules against unverified claims. But locking the thread didn't stop the conversation. It just moved to other platforms, fragmenting into dozens of parallel discussions, each pulling the original post in different directions. Here's what made the 4chan leak impossible to completely dismiss some of the claims were verifiable. The nickel without iron observation, for instance. And when people started checking published spectroscopic data, they found the Very Large Telescope had confirmed nickel presence and explicitly noted the unusual absence of iron in their August 21st paper. The anonymous poster had been right about that detail, which made people wonder what else they might be right about. There's another layer to this story, one that connects 3I Atlas to an event that occurred nearly half a century ago. An event that remains one of the greatest mysteries in the search for extraterrestrial intelligence. August 15, 1977, a warm summer night in Ohio. The Big Ear radio telescope was conducting its automated survey of the sky, listening for unusual signals that might indicate technological civilizations beyond Earth. The telescope itself was remarkable. A flat reflector the size of 3 football fields, built on the grounds of Ohio State University's Perkins Observatory. It couldn't move. Instead, it relied on Earth's rotation to sweep different portions of the sky through its field of view, like a cosmic lighthouse in reverse, standing still while the universe turned before it. The telescope recorded data on continuous feed paper, a roll of perforated sheets, tracking signal intensity, across 72 channels covering different radio frequencies. Each channel was represented by a column of numbers and letters, a code indicating signal strength. Most of the time, the paper showed ones and twos, background noise, the quiet hiss of cosmic radiation, the static of a universe fundamentally at rest. But at 10:16 p.m. Eastern Time, something changed. Channel 2 began registering higher values. 3, 4, 5. The signal was strengthening as the radio source entered the telescope's beam, rising like a cosmic dawn. 6, 7. By the time the signal peaked, it reached the maximum value the system could print, the letter U, representing intensity far beyond normal background. The signal maintained that extraordinary strength for 72 seconds, exactly the time it would take for a fixed position source to drift through the telescope's narrow beam as Earth rotated. Then it declined symmetrically. U back down through the alphabet and numbers fading as the source exited the beam's edge, a perfect bell curve.
A rise, a peak, a fall. The signature of a point source, not some broad wash of interference. Something specific, something localized. The signal intensity peaked at approximately 212 Janskis, about 30 times stronger than background noise. It was narrowband, confined to a very specific frequency range rather than spread across the spectrum. Natural cosmic phenomena tend to produce broadband noise. Narrow signals suggest artificial generation, something designed to stand out, and the frequency was significant, 1420.456 megahertz, the hydrogen line. The most abundant element in the universe, the frequency at which neutral hydrogen naturally emits radiation. Any technological civilization studying the cosmos would know this frequency intimately. It's the universal channel. The obvious choice for attempting interspecies communication. The signal came from the direction of Sagittarius, near the constellation's densest star fields pointing toward the galactic core. And then nothing.
For 48 years, despite hundreds of follow-up observations, thousands of hours of listening time pointed at the same region of sky using increasingly sophisticated instruments, the signal has never repeated. Just that one burst. 72 seconds. Then eternal silence. Until Avi Loeb ran the numbers on 3i Atlas, he calculated where the object would have been on August 12, 1977, just 3 days before the WOW signal was detected. The answer: approximately 600 astronomical units from Earth, roughly 600 times the distance between Earth and the Sun. Far out in the outer solar system, well beyond Neptune's orbit. But more importantly, he calculated what direction 3i Atlas was coming from at that time. Right ascension, 19 hours 40 minutes. Declination, minus 19 degrees. The WOW signal came from right ascension, 19 hours 25 minutes. Declination, minus 27 degrees. The two directions are separated by approximately 9 degrees. In the vastness of space, with random objects coming from literally any possible direction across the entire celestial sphere, the probability of this alignment is about 0.6%. Not impossible, but deeply suspicious. Loeb didn't stop there. He asked the next logical question: if 3i Atlas sent the WOW signal from 600 AU away, how powerful would the transmitter need to be? The math is straightforward. The detected intensity was between 54 and 212 Janskis across a 10 kHz bandwidth. At 600 AU distance, that corresponds to a transmitter output between half a gigawatt and 2 gigawatts. For reference, a typical nuclear power plant on Earth produces about 1 gigawatt. So we're talking about nuclear power plant levels of energy focused into a narrow radio beam. Not impossible for an advanced civilization. Actually quite reasonable if you're trying to send a detectable signal across interstellar distances without wasting energy on omnidirectional broadcasting. There's another detail that makes the connection harder to dismiss. The WOW signal was observed at 1420.456 megahertz, blue shifted by approximately 10 kilometers per second toward Earth, relative to the hydrogen line. That blue shift indicates the source was moving toward us. 3i Atlas is currently approaching the Sun at about 60 kilometers per second. Loeb suggests that if the object has maneuvering capability, it could have been moving slower in 1977, then accelerated after detecting habitable zone planets in our solar system. A reconnaissance pulse. A radar scan. Checking for signs of technological civilization before committing to a closer approach. Think about what that timeline would mean. 1977. A powerful radio burst aimed toward Earth's solar system. We see you. We've detected your radio transmissions. We're coming. 2025 physical arrival. 48 years of travel at 58 kilometers per second from 600 astronomical units equals approximately 48 years. The math lines up perfectly, almost too perfectly. It suggests the WOW signal wasn't a survey ping at random stars. It was an announcement, a declaration of intent. We're coming. We've detected your technological signatures. Here's proof we're capable of directed transmission. We'll arrive in about 5 decades. That would have been sufficient warning time for a civilization to prepare, to develop better detection capabilities, to build infrastructure for observation and potential communication, to have public discourse about how to respond to visitors from beyond. We had 48 years, and we spent most of that time arguing about whether the signal was real where it came from, whether it was natural or artificial, whether we should respond or stay silent. We never reached consensus. We never prepared protocols.
We never unified our response strategy. And now, the object that might have sent that signal is here, has been here since July, passed Mars in October, reaches perihelion this month, emerges in December. The timeline suggests intentionality, calculation, a carefully planned trajectory designed to give us time to notice, time to prepare, time to decide how we want to interact, or it's all coincidence. The wow signal was some natural phenomenon we still don't understand. 3I Atlas is a comet with unusual chemistry. The directional alignment is statistical luck. The 48-year gap is numerological apophenia, seeing patterns where none exist. But here's what makes the silence so conspicuous. Not a single major radio telescope has publicly reported attempting to listen to 3I Atlas. The Very Large Array hasn't announced observations. Green Bank hasn't published data. The Arecibo telescope, which might have been perfect for this, was destroyed in 2020 and no longer exists. China's FAST telescope, the world's largest single-dish radio observatory, has been oddly quiet. Even SETI, the organization literally dedicated to finding evidence of extraterrestrial intelligence, hasn't publicly announced any monitoring efforts directed specifically at 3I Atlas. The silence from the radio astronomy community is deafening. Now, to be fair, there could be practical reasons. Radio telescope time is expensive and competitively allocated. Facilities book observations months in advance. The WOW signal connection might seem too tenuous to justify resources. Limited observing time goes to higher priority targets with better theoretical justification. Or maybe they have looked. Maybe they found nothing. Radio silence from 3I Atlas. No transmissions, no signals, just an inert rock from another star system behaving exactly as a natural comet should. And finding nothing isn't newsworthy. It doesn't warrant press releases, so they simply moved on to other projects. Or maybe they've looked and found something, and they're trying to figure out what it means before going public. Trying to verify it's not equipment error, not terrestrial interference, not some artifact of signal processing. Trying to understand whether what they detected requires the extraordinary announcement that would follow. We don't know, because they haven't told us. And in that silence, the speculation grows. If 3I Atlas is the source of the WOW signal, then it's been aware of us for at least 48 years. It's been watching, listening, moving slowly but deliberately toward our solar system, and now it's here. December will tell us whether radio astronomers point their instruments at the re-emergent object and finally listen properly, whether anyone admits to already having listened, whether the silence continues or breaks under the weight of what might be discovered. 48 years ago, someone or something might have said, "We're coming." The question is whether anyone said, "We heard you." Now we must do something critical, something that separates responsible investigation from conspiracy thinking. We must examine competing explanations with intellectual honesty. We must give the most probable hypothesis its proper weight. This is speculation clearly labeled. The following represents the mainstream scientific position, the natural explanation, the interpretation supported by most astronomers, most data, and most prior experience with comets. 3I Atlas is almost certainly a natural object. Let's examine why that remains the most likely explanation, representing approximately 60% probability in any reasonable Bayesian analysis. First, the observational baseline 3I Atlas exhibits clear cometary behavior. It has a coma, a cloud of gas and dust surrounding the nucleus. It developed a tail by late August as solar radiation pushed material away from the sun.
It shows spectroscopic signatures consistent with volatile sublimation, carbon dioxide, cyanide, trace water vapor, organic compounds. Everything we associate with comets. NASA's position, articulated by Tom Statler and other program scientists, is that suggestions of artificial origin are absolute nonsense. Not because the anomalies don't exist, but because natural explanations remain adequate to explain them. Let's address each anomaly systematically. The CO2-rich composition. Yes, unusual, yes, among the highest ratios ever recorded, but not unprecedented. Some comets do form in regions where carbon dioxide dominates over water ice. This occurs in the coldest, most distant parts of protoplanetary disks, where CO2 can condense more readily. If 3I Atlas formed in the outer regions of its parent star system, particularly if that system had different chemical abundances than our Sun, extreme CO2 dominance becomes explainable through known processes. We're discovering that exoplanetary systems show remarkable chemical diversity. Different stellar types, different formation histories, different initial conditions produce planets and comets with compositions that would seem bizarre by solar system standards. 3I Atlas's chemistry might simply reflect an alien stellar environment, alien in the sense of foreign, not technological. The nickel without iron problem, admittedly more challenging. In standard stellar nucleosynthesis, nickel and iron form together and remain together, but standard assumes typical supernova conditions. We know that rare stellar processes, peculiar neutron-star mergers, exotic asymmetric supernova, specific capture reactions in stellar atmospheres can fractionate elements in unexpected ways. Perhaps 3I Atlas formed from material processed through one of these rare events. Perhaps its parent system experienced unusual stellar evolution that altered normal chemical ratios. Perhaps we're simply seeing evidence of astrophysical processes that occur rarely enough that we haven't documented them in detail yet. The universe is large. Given enough stars, enough planetary systems, enough time, even extremely rare conditions occur somewhere. We might be witnessing chemistry that's statistically unlikely but physically possible. The thermal contradictions explained through internal structure. Comets aren't solid chunks of ice. They're porous rubble piles, loosely aggregated material with significant empty space between particles. This structure affects how heat propagates through the body. A comet with particularly high porosity could show cold surface temperatures while still outgassing actively from warmer interior regions. The thermal physics are complex, involving sublimation vapor diffusion through porous media, radiative cooling, and rotational effects. Unusual structure could produce unusual thermal signatures without requiring anything beyond standard cometary physics. Now the trajectory statistics. Yes, the orbital inclination of 4.89 degrees is unusual. Yes, the probability is low, 1 in 500. But consider this: how many interstellar objects pass through the galaxy? Estimates suggest billions. Even within our local stellar neighborhood, thousands of objects might be in transit at any given moment. If we're detecting 1 or 2 per decade with current instruments, we're seeing a tiny fraction of what's actually out there. Given large numbers, rare events become inevitable. An orbital inclination that occurs randomly 1 in 500 times will show up regularly when thousands of objects are available. The close planetary encounters, yes, improbable, at 1 in 20,000 for that specific combination. But again, sample size matters. With enough interstellar visitors, some will thread unusual paths through the solar system purely by chance. Improbable doesn't mean impossible. It just means we should verify carefully before jumping to extraordinary conclusions. And the perihelion timing. Earth and solar conjunction on October 29th is unfortunate but geometrically determined. Objects arriving on hyperbolic orbits from interstellar space don't choose their perihelion dates. Those dates are fixed by initial conditions, velocity direction, and distance when they enter the Sun's gravitational influence. The fact that Earth happens to be on the opposite side of the Sun during perihelion is coincidence. Perhaps rare coincidence, but still explicable through orbital mechanics without invoking intent. Historical precedent supports caution. Humans have repeatedly mistaken natural phenomena for artificial signals or structures. In 1967, astronomers discovered pulsars rapidly rotating neutron stars emitting regular radio pulses. The signals were so precisely timed that the first detection was initially designated LGM-1, Little Green Men. They seriously considered whether they'd found an artificial beacon. Turned out to be exotic physics, not extraterrestrial engineering. In 1910, when Earth passed through the tail of Halley's comet, people panicked. They thought toxic gases would poison the atmosphere. They sealed windows, bought gas masks, held prayer vigils. The comet passed harmlessly. The panic was unfounded. Oumuamua in 2017 showed non-gravitational acceleration that couldn't be explained by observed outgassing. Loeb proposed a light sail. Most astronomers concluded it was simply outgassing we couldn't see perhaps from very cold ices that don't produce visible comas. Natural explanation remained favored despite observational gaps. The pattern is clear. When faced with anomalies, the proper scientific response is to first exhaust natural explanations before invoking technology or intelligence. Extraordinary claims require extraordinary evidence. Carl Sagan's principle remains valid. And we don't yet have extraordinary evidence for 3I Atlas. We have unusual chemistry, unlikely geometry, and frustrating data gaps. But unusual isn't impossible. Unlikely isn't artificial, and data gaps get filled eventually without requiring revolutionary explanations. Multiple peer-reviewed papers have analyzed 3I Atlas and concluded it's consistent with natural cometary processes. Hubble observations show light curves matching expected behavior for rotating icy bodies. Spectroscopic data, while showing unusual ratios, still falls within the range of known chemistry. No detection of artificial transmissions has been reported. No propulsion signatures observed. The most likely explanation remains the simplest: we're looking at a comet, an unusual comet from a planetary system with different chemical conditions than ours. A comet that happened to thread an improbable trajectory through our solar system. A comet that arrived at an inconvenient time for observation, but still, fundamentally, just a comet. This explanation deserves its 60% probability weight. It's supported by the most evidence, requires the fewest assumptions, and aligns with our understanding of how the universe actually works. That doesn't mean it's certainly correct. It means it's probably correct. And probability matters when evaluating competing hypotheses. We'll know more in December. If the post-perihelion trajectory remains hyperbolic, if 3I Atlas continues on its escape path and gradually fades from view, then this natural explanation will be effectively confirmed. The anomalies will remain interesting footnotes in astronomy papers, curiosities to be explained through better models of interstellar chemistry and orbital dynamics. And we'll wait for the next interstellar visitor, knowing that Vera Rubin Observatory will find them regularly now. We'll have larger sample sizes, better statistics, more opportunities to understand how common or rare these properties actually are. For now, the natural explanation holds. It's the baseline, it's what the data most clearly supports, but it's not the only possibility. And intellectual honesty requires examining alternatives even when they push boundaries of what we typically consider. Let's do that next. Now we move into territory that's still natural, still explainable through physics, but considerably stranger. This represents perhaps 25% probability edge cases in our understanding of cosmic processes. This is speculation, but grounded in actual science. What if 3I Atlas is natural but represents phenomena we haven't encountered before? What if it's pushing our models without breaking them? The universe is stranger than we give it credit for. Earth's experience our local chemistry. The objects we've studied in our solar system, these represent a tiny sample of cosmic possibility. We've analyzed fewer than 1,000 comets in detail. We've detected only 3 confirmed interstellar objects. We've directly studied planetary systems around perhaps a few dozen stars. Extrapolating from that limited sample to predict everything that's possible is hubris. Consider the cue ball hypothesis mentioned in the 4chan leak. Dismiss the anonymous source, but examine the physics. Cue balls are theoretical objects from supersymmetric particle physics. They're non-topological solitons, stable configurations of quantum fields that resist decay into simpler states. In most models, cue balls exist only at subatomic scales. But some theoretical frameworks allow macroscopic cue balls objects meters, kilometers, even planet-sized, while maintaining quantum coherence. If stable, a macroscopic cue ball would have bizarre properties. It would be incredibly dense, far denser than normal matter because it's held together by quantum field energy rather than electromagnetic or gravitational forces. Yet it might appear diffuse from outside depending on how its quantum fields interact with normal matter and light. It could absorb and redistribute energy instantaneously across its entire structure through quantum entanglement. This would explain thermal contradictions, cold exterior while actively releasing material. Because energy flows through the object, don't obey normal thermodynamic constraints. It could preferentially produce certain isotopes through quantum field interactions with the vacuum, potentially explaining nickel without iron chemistry if the cue ball's internal state favors specific nuclear configurations. This sounds like science fiction, but it's actually published physics appearing in peer-reviewed journals discussing exotic matter and early universe cosmology. The question isn't whether cue balls are theoretically possible. Most physicists agree they are. The question is whether they can exist at macroscopic scales and remain stable over cosmological timescales. If the answer is yes, then 3I Atlas could be natural in the sense that it arose from physical processes without intelligent design, but artificial in the sense that it's not made of normal atoms and doesn't behave like normal matter. Another possibility fragment of an exotic exoplanet. We're discovering that planetary formation produces astonishing diversity. Super-Earths with diamond mantles, carbon planets with graphite crusts and oceans of liquid hydrocarbons, ice giants with superionic water, a bizarre state where oxygen atoms form a crystalline lattice while hydrogen ions flow freely like liquid. What if 3I Atlas is a fragment from a planet with core composition we haven't imagined? A world that differentiated in unusual ways, concentrating nickel at the surface while iron sank deeper. A cryogenic biosphere, a planet where life evolved in liquid nitrogen or methane rather than water-producing organic chemistry based on entirely different solvents. Such a world, if destroyed by stellar catastrophe or planetary collision, could produce fragments with chemistry that seems impossible by solar system standards. We'd be looking at debris from an alien world, alien in the geological sense, not biological, with surface composition reflecting that world's unique formation conditions. The fragment theory explains the CO2 dominance if the planet's atmosphere was CO2 rich. It explains unusual chemistry if differentiation processes work differently than on Earth. It explains the mass-to-size ratio if internal structure is complex, perhaps layered, perhaps hollowed by ancient geological processes we don't understand. Then there's electromagnetic phenomena we're only beginning to comprehend. The LASCO C3 coronagraph images showing geometric patterns in 3I Atlas's plasma field cross-shaped structures, stratified color layers, might not be artifacts. They might represent natural magnetohydrodynamic processes we haven't fully characterized. When plasma interacts with complex magnetic fields, it can create remarkably regular structures. We see this in solar prominences in Earth's aurora in the magnetospheres of planets. Under the right conditions, plasma naturally organizes into geometric patterns through purely physical processes: field line reconnection, density, stratification, resonant wave modes. Perhaps 3I Atlas has an unusual magnetic field, possibly a frozen-in remnant from its parent star's magnetic environment. As it approaches the Sun, interaction between this field and solar wind creates plasma structures that appear artificial but are entirely natural electromagnetic responses, or consider collision remnants. What if 3I Atlas isn't a single object, but two interstellar bodies that collided long ago, merging into a composite with mixed composition? One object nickel-rich, the other iron-poor. The collision creates a hybrid with contradictory chemistry. Interstellar space is vast and empty. Collisions should be rare, but given enough time, millions or billions of years, rare events occur, and merged objects could have internal structures that don't make sense from formation models because they weren't formed, they were assembled through catastrophic impact. Each of these explanations pushes boundaries of known physics. Each requires conditions we haven't directly observed, but none requires technology, none requires intelligence.
They remain natural phenomena, just exotic natural phenomena at the edge of what current models accommodate. This is important to emphasize. Unusual doesn't mean artificial. The universe's natural creativity exceeds human imagination. Before we invoke alien probes, we should exhaust exotic but natural possibilities. These edge case hypotheses collectively represent perhaps 25% probability. Less likely than straightforward comet, more likely than technological artifact. They occupy the middle ground where science fiction and peer-reviewed physics overlap. We won't definitively rule them out without more data, but December's observations will constrain possibilities. If 3I Atlas shows behaviors completely inconsistent with any known natural process, if it maneuvers in ways that require propulsion, if it transmits organized signals, if it demonstrates clear, purposeful action, then we'd be forced toward the third hypothesis. The one that 15% probability suggests we should at least consider. Let's examine that now.
This is speculative. This requires extraordinary evidence we don't yet have. But intellectual honesty and the principle of examining all possibilities demand we consider it. One hypothesis worth perhaps 15% probability based on current data suggests 3I Atlas might be technological in origin. Let's be clear about what this means and doesn't mean. We're not talking about biological aliens in spacecraft. We're not suggesting little green creatures piloting a ship. Any civilization capable of sending objects across interstellar distances would likely have transcended biological form millions of years ago. We're talking about a probe, an automated system, a machine intelligence designed to explore, observe, perhaps report back across the vast distances of space. Here's why this hypothesis deserves consideration despite its low probability. The wow signal correlation. If 3I Atlas was at approximately 600 AU in 1977 in the right direction to have transmitted that signal, then the 48-year travel time to current position is exactly what you'd expect from a probe moving at 58 kilometers per second. That's not magic technology, that's patient exploration at achievable velocities. For reference, Voyager 1 is currently traveling at 17 kilometers per second. It's the fastest human-made object relative to the Sun. A civilization only moderately more advanced than ours, say 1,000 years ahead, technologically could plausibly build probes traveling at 50-60 kilometers per second using nuclear pulse propulsion fusion drives or ion engines operating continuously over decades. Breakthrough Starshot. A current human initiative proposes sending tiny probes to Alpha Centauri at 20% light speed using laser-pushed light sails. That's 60,000 kilometers per second, 1,000 times faster than 3I Atlas. The technology is theoretically sound, just requiring massive infrastructure investment. So 3I Atlas's velocity isn't extraordinary, it's achievable with physics we understand. The trajectory optimization, that 4.89-degree inclination, those planetary encounters. The October 29th timing, if designed rather than random, they make perfect sense for a reconnaissance mission. You'd want to pass close to multiple planets to gather comparative data. You'd want to align with the ecliptic plane where habitable zone worlds typically orbit. And if planning an Oberth maneuver to capture into solar orbit, you'd time it for when the civilization you're studying can't observe the propulsive burn. Loeb calculated the delta V required for solar capture at perihelion approximately 25 kilometers per second. That's significant but manageable for a craft designed for interstellar travel. The reverse Oberth maneuver is standard orbital mechanics, just applied in a context we've never done ourselves because we've never sent anything to another star system. The power requirements. If transmitting the WOW signal 0.5 to 2 gigawatts is substantial, but not impossibly so, a spacecraft designed to operate for millions of years would need onboard power generation. Nuclear reactors, fusion systems, energy harvesting from stellar radiation. All theoretically possible. Waste heat from such systems would create thermal signatures, perhaps explaining why the object remains cold despite activity. Active thermal management radiating waste heat in directions we're not observing. The chemical anomalies, if not natural chemistry, then perhaps industrial chemistry. Materials science. A craft's outer layers might be constructed from specialized alloys, perhaps nickel-rich for specific electromagnetic properties.
The CO2 dominance might represent propellant exhaust or thermal management fluid being vented. We're speculating now, building castles from sand. But the speculation has internal logic. It's consistent with physics. It's just invoking technology rather than exotic natural processes. And then there's the Mars connection. If 3I Atlas deliberately approached Mars, that makes strategic sense. Mars is far enough from Earth that activities there are difficult to observe in real time with current technology. It has resources, water, ice, minerals, a solid surface. It once had a magnetosphere and atmosphere, perhaps even ancient life before those were lost. If you're surveying the solar system for habitability, Mars is interesting. If you're establishing infrastructure, Mars is useful. If you're checking on earlier missions or equipment deployed centuries ago, Mars is worth a close approach. The thermal anomalies in Terra Meridiani structures those formations, showing consistent internal heat across multiple observation periods, could be evidence of active systems. Power generation, life support for automated equipment. Something maintaining temperature against Martian cold. This is where speculation edges toward conspiracy theory, where we're building elaborate narratives from minimal evidence. But here's the thing, it's not impossible, just improbable given current data. The critical question isn't whether an advanced civilization could build interstellar probes. Of course, they could. The question is whether we have sufficient evidence that 3I Atlas is one of them. And honestly, not yet. We have anomalies, we have coincidences, we have silences and missing data, but we don't have a transmission clearly of artificial origin. We don't have observed propulsion. We don't have unambiguous geometric regularity. We don't have any single piece of evidence that can't be explained through natural processes, however exotic. This hypothesis remains low probability, not because it's impossible, but because extraordinary claims require extraordinary evidence, and we haven't reached that threshold. December might change that. If the trajectory shows orbital capture, if 3I Atlas has transitioned from hyperbolic to elliptical orbit after perihelion, then we'd know a maneuver occurred. Natural capture is possible, but requires highly specific conditions. Deliberate braking would become the simpler explanation. If radio telescopes detect organized transmissions, anything with clear information content, repetitive patterns, or modulation inconsistent with natural processes, that would be extraordinary evidence. If subsequent observations show geometric structures, antenna arrays, thermal signatures indicating industrial processes, that would demand reconsideration. But absent such evidence, this hypothesis remains speculative, worth considering,
worth investigating, worth keeping on the table while we accumulate more data, but not yet justified as the primary explanation. That's intellectual honesty. That's the difference between responsible investigation and conspiracy thinking. We examine the possibility without committing to it prematurely. We watch, we measure, we let the data constrain our conclusions rather than forcing conclusions onto ambiguous data. If 3I Atlas is technological, we'll know soon enough. December will clarify. If it's natural, whether ordinary comet or exotic physics, December will clarify that too. Until then, we hold multiple hypotheses simultaneously weighted by their probability based on available evidence. That's how science works. That's how we approach the unknown responsibly.
Let's return to Mars, because whatever 3I Atlas ultimately proves to be its October 3rd close approach to the red planet represents a data point that demands examination. Mars has always been a strange place. Not just geologically, though the ancient river valleys, the massive volcanoes, the polar ice caps, the evidence of liquid water billions of years ago certainly qualify as fascinating, but strange in terms of what we keep finding that doesn't quite fit comfortable explanations. In 2015, NASA's Curiosity rover photographed what looked like a perfectly rectangular stone, too geometric to be natural erosion, too regular in its proportions. The image went viral briefly before NASA identified it as a ventifact, a rock shaped by windblown sand over millions of years, into sharp edges and flat faces. Plausible. Wind erosion does create geometric shapes. But then similar formations started appearing in other locations, and the probability of multiple ventifacts forming with such regular geometry scattered across different regions of Mars starts to accumulate into something worth questioning. Then there were the blueberries, tiny, perfectly spherical pebbles discovered by Opportunity in 2004. Despite being gray, they were nicknamed blueberries because of their size and shape. Their formation was eventually explained through mineral precipitation in water-soaked rock, followed by erosion exposing the harder spherical cores. Natural process. But the distribution was odd. They appeared in clusters, almost as if manufactured and scattered, and their composition showed hematite concentrations unusual for natural formation at those specific locations. None of this proves anything artificial. Martian geology is complex, poorly understood, operating under atmospheric conditions dramatically different from Earth. Erosion patterns, mineral formation. Everything works differently in thin CO2 atmosphere with no liquid water, but it creates context for what's been observed in Terra Meridiani. Amateur image analysts poring over high-resolution orbital photographs from Mars. Reconnaissance orbiter have identified vertical structures in this region, not small rocks, large formations, some appearing to be several kilometers tall, standing at angles, inconsistent with typical layered sediment. NASA's explanation: exotic geology. Layers of rock with different hardness levels eroding at different rates, creating structures that look artificial under certain lighting, but are entirely natural when examined in proper context. Again, plausible. Mars is full of unusual formations. The face on Mars turned out to be a mesa, a trick of light and shadow combined with human pattern recognition. Pareidolia is powerful. We see what we expect to see, especially in low-resolution imagery.
But then 3I Atlas made its close approach, and suddenly those old anomalies were being re-examined. The vertical structures, the geometric rocks, the spherules, the ancient river valleys that stopped flowing millions of years ago for reasons we still don't entirely understand. What if they weren't geological? What if Mars has been occupied? Not recently, not by anything living now, but occupied in the past. A way station, a construction site, a testing ground. And what if 3I Atlas's trajectory wasn't random at all, but deliberately designed to pass close to Mars to check on something left there long ago? This is where narrative becomes difficult to navigate. where we're moving from verifiable anomalies, real measurements, real images, real calculations showing unlikely alignments into pure speculation about ancient civilizations and long-term surveillance. The evidence doesn't support drawing firm conclusions, but it does support asking uncomfortable questions. Why did 3I Atlas pass so close to Mars specifically? Why not Venus, which is actually closer to its perihelion point? Why not Earth if observation of intelligent life is the goal? Mars makes sense as a staging ground. It's far enough from Earth that activities would be difficult to observe in real time. It has resources, water, ice, and polar caps, and subsurface deposits minerals, a solid surface suitable for infrastructure. It once had a magnetosphere, a thicker atmosphere, possibly liquid water on its surface. Perhaps even simple life billions of years ago before atmospheric loss and magnetic field collapse rendered it inhospitable. If you were designing a way station between interstellar space and the inner solar system, Mars would be the logical choice. Far enough from the habitable planet to avoid detection, close enough for efficient operations. And then there's the thermal paper. In mid-November 2025, European researchers published a technical analysis in a specialist journal, the kind of publication with circulation measured in hundreds rather than thousands, read primarily by planetary geologists and thermal modeling specialists. The paper discussed thermal anomalies in Terra Meridiani region, dry technical writing that normally wouldn't attract attention outside narrow academic circles. The research team had been analyzing infrared data from multiple Mars orbiters. Mars Odyssey's Themis instrument, Mars Reconnaissance, orbiters, Marcy camera, ESA's Mars Express Omega spectrometer. They were building a comprehensive thermal map of the region, tracking how surface temperatures varied with time of day, season, and local geology. But embedded in an appendix was something interesting, a table showing temperature variations at sites where those controversial vertical structures are located, measured over time, tracked across Martian seasons. The data was meticulous. Measurements taken at dawn, noon, dusk, and midnight, summer and winter observations, multiple years of continuous monitoring, the kind of data set that takes patience and careful calibration to assemble, and the pattern was undeniable. The structures are warmer than surrounding terrain. Not dramatically, we're talking about temperature differences of 2 to 5 degrees Kelvin, depending on time and season, but consistently warmer. Through Martian winter, when ambient temperatures plunge to 190 Kelvin, the structures maintain slightly elevated temperatures. Through summer, when surface rocks bake under thin atmosphere and intense sunlight, the structures remain measurably warmer even after sunset when normal rock rapidly cools. The temperature excess persists through Martian night, through dust storms that obscure solar heating, through every condition that should equilibrate temperatures across uniform geology. The paper's authors suggested unusual mineral composition. Certain rocks absorb and retain heat differently than others. Iron-rich formations can stay warmer longer after sunset than silicate rocks. But there's a problem with that explanation. The heat signature doesn't follow expected patterns for passive thermal retention. It's too constant, too stable, as if there's an internal heat source maintaining temperature rather than just residual warmth from solar heating. The paper acknowledged this anomaly but didn't press the point. They called for more study, additional observations. Standard academic caution when dealing with results that don't fit established models. But if you read between the lines, if you understand the implications of consistent internal heat in structures that should be cold rock, you start to see why this might be significant. Things that generate their own heat are either geologically active or technologically powered. Mars doesn't have significant volcanic activity, no plate tectonics, no known processes that could explain localized heat generation in Terra Meridiani specifically, which leaves technology. If the structures are artificial, not natural geological formations, but constructed installations, then internal heat makes sense. Power generation. Equipment operation. Systems maintaining function across millions of years, waiting for something. Waiting for 3I Atlas to arrive. The paper's thermal observations extend through September 2025. October data wasn't included because it hasn't been fully processed yet, but the September measurements showed temperature increase. Slight, but measurable. As if something in those structures became more active as 3I Atlas approached, like a system powering up, preparing for arrival, anticipating the close approach and adjusting operational state accordingly. This is interpretation layered onto data that admits multiple explanations. The temperature increase could be seasonal, could be measurement error, could be unrelated to 3I Atlas entirely, but the timing is notable. And the fact that this paper appeared in November, just before December emergence, suggests someone wanted this information available before the next round of observations, before whatever happens next changes the context for interpreting thermal data from Mars. If construction is happening, if something is actively building or maintaining infrastructure on Mars right now, then the question becomes building what and for whom? A base, an outpost, a research station, a mining operation, a way station for missions going deeper into the solar system or back out to interstellar space, or something else. Something we wouldn't recognize because our framework for understanding construction is limited to human needs and human scales. Maybe they're building a beacon, a navigation marker that helps other interstellar visitors find the system and understand its properties. Maybe they're building a defensive installation, something designed to detect and potentially deter threats. An early warning system for the inner solar system. Maybe they're building a garden, a biological preservation facility storing genetic information or living specimens from civilizations throughout the galaxy. Or maybe they're building something so far beyond our current comprehension that we wouldn't recognize it even if we saw it directly. Like an ant trying to understand why humans build particle accelerators. The purpose and function exist at a cognitive level the ant can't access. That's the humbling possibility that even if we discovered what's being built, we wouldn't understand what it's for. Mars might not be virgin territory, it might not be unclaimed ground waiting for human colonization, it might be someone's archaeological site, someone's industrial zone, someone's long-term experiment in planetary evolution. And 3I Atlas's October 3rd flyby might have been inspection, making sure our activities with rovers and landers aren't causing problems, checking whether we're approaching understanding of what we're looking at, deciding whether we're advanced enough to be brought into the loop or whether we need more time to develop before being told what Mars actually is. December won't answer these questions, but December will tell us whether 3I Atlas stayed, whether it captured into orbit and remains in our solar system, whether it's here for more than just a flyby, and that will change how seriously we need to take the Mars question.
There's a document that circulates quietly in certain corners of the internet. Not classified exactly, but not widely discussed either. It's called the Brookings Report, formerly titled Proposed Studies on the Implications of Peaceful Space Activities for Human Affairs. It was commissioned by NASA in 1960, delivered to Congress in 1961 during the early optimism of the space age, when everything seemed possible. Most of it deals with mundane policy questions, international cooperation in space scientific research priorities, economic implications of satellite technology. Standard think tank material, but there's a section page 215 of the original document that discusses something else entirely. What happens if we discover evidence of extraterrestrial life? The report's assessment is sobering. Such a discovery could be profoundly destabilizing to human civilization. It argues that societies throughout history have collapsed when confronted with technologically superior civilizations, that the mere knowledge of more advanced beings existing elsewhere could trigger similar collapses in human culture, particularly in religious and philosophical frameworks that place humanity at the center of cosmic significance. The recommendation reading between carefully diplomatic language is that such information should be carefully managed, released gradually, contextualized appropriately, not hidden exactly, but not announced without preparation for social and psychological consequences. That was 1961, over 60 years ago. Since then, we've had decades of UFO sightings, government investigations, classified reports, slow drips of information suggesting that something is being observed in our skies that we can't explain with conventional technology.
The 2021 Pentagon report on unidentified aerial phenomena admitted that a majority of incidents remain unexplained. It carefully avoided using the word extraterrestrial, but acknowledged that some observed objects display capabilities beyond current human technology. That was significant, the government essentially confirming that things are flying around that we can't identify and don't understand. But it was also carefully controlled. The report raised questions without answering them. It acknowledged mystery without providing solutions. It told us just enough to know something is happening, but not enough to understand what. 3i Atlas fits the same pattern. NASA has a dedicated page tracking the object. They've provided basic orbital parameters, size estimates, composition data, but the high-resolution images from the Mars flyby remain unreleased. The detailed spectroscopic analysis from multiple observatories is still being processed.
Radio telescope observations looking for potential transmissions haven't been mentioned. We get enough information to know an interstellar object is passing through, but not enough to draw conclusions about what it might be beyond probably a comet. The government shutdown occurring during the Mars flyby observations feels like convenient timing, as if someone knew that was the critical window and made sure data release would be delayed, giving time to review what was captured, decide what can be shown publicly and what needs to remain classified. This sounds like conspiracy thinking. And maybe it is, but here's the thing about conspiracy theories: sometimes they're correct. Sometimes powerful institutions do coordinate to manage information flow. Sometimes there are legitimate reasons for withholding data temporarily. The question is whether those reasons serve public interest or institutional interest.
If high-rise captured images showing clear artificial structures near 3i Atlas during the Mars flyby, that would be revolutionary, world-changing, the kind of discovery that rewrites textbooks and reshapes human understanding of our place in the cosmos. It would also trigger exactly the kind of societal disruption the Brookings report warned about. Religious frameworks would need re-examination. If we're not unique, if other intelligent species exist, what does that mean for theological traditions that place humans in special relationship with the divine? Are other species also created in God's image? Do they have their own salvation histories? Or does the very concept of the divine need reconsideration? Some religious thinkers have already grappled with these questions hypothetically. The Vatican, for instance, has stated that the existence of extraterrestrial life wouldn't contradict Catholic theology. Brother Guy Consolmagno, a Jesuit astronomer, has written about how alien intelligence might fit within existing theological frameworks. But theoretical acceptance and emotional reality are different things. When faced with actual evidence, not philosophical speculation, how would faith communities respond? For some, it might deepen faith evidence that creation is even more magnificent than imagined, that divine creativity extends beyond our small world. For others, it might trigger profound crisis. If salvation history is universal, did other worlds have their own equivalent of Christ? If it's not universal, does that mean we're not actually central to divine plan? These questions don't have comfortable answers. Philosophical assumptions would collapse. If we're not the only consciousness, not the only intelligence, then centuries of anthropocentric philosophy, from existentialism to humanism to most ethical frameworks, requires fundamental revision. Sartre's existentialism places human consciousness as the source of meaning in an otherwise meaningless universe.
But if consciousness exists elsewhere, perhaps more ancient and developed than ours, does meaning originate independently in multiple locations, or is there some universal framework we've been unable to perceive from our isolated vantage point? Humanist ethics base moral frameworks on human flourishing and dignity. But what happens when human is just one instance of intelligent being? Do we need posthumanist ethics that can accommodate multiple forms of consciousness with potentially different values, different conceptions of flourishing, different ideas about what constitutes a good existence? Economic and political systems might destabilize. National borders seem parochial. When confronted with the reality that our entire species is a single small civilization on one planet among many. Resource conflicts that drive wars need reframing.
Existential risks, climate change, nuclear weapons pandemics become more urgent because they threaten humanity's ability to join whatever larger community exists beyond our atmosphere. So maybe the images are being withheld, not because they show nothing interesting, but because they show something too interesting, something requiring careful preparation before public release, something that changes everything. Or maybe they really do just show a fuzzy dot, and bureaucratic delays during a government shutdown prevented timely publication of scientifically routine observations. We don't know. That's the frustrating part. We're left to speculate because institutions that have the data aren't sharing it in the time frame we'd expect. There's a cost to this approach. When institutions manage information, they erode trust. People recognize when they're being handled. When data is selectively released or carefully spun or conspicuously absent, it triggers suspicion that something is being hidden. And that suspicion can be more damaging than truth would have been. Because while truth provides certainty, suspicion breeds endless speculation. People fill information gaps with increasingly extreme theories. The absence of official explanation becomes evidence of conspiracy. We're seeing that pattern play out right now. The missing Mars data, the social media suppression, the coordinated silence. Maybe there's legitimate reason for caution. Maybe what was observed needs careful analysis before public announcement. Maybe institutional processes are just slow. But the longer the silence continues, the more people assume something is being hidden, the more elaborate the theories become, the less trust exists in official sources. And that makes eventual revelation even more destabilizing, because people no longer believe anything they're told. So there's a dilemma with no good solution. Release information immediately and risk destabilizing panic. Manage the release carefully and risk erosion of trust that makes eventual revelation even more chaotic. Different costs for different choices. No perfect path forward. And December is when those choices crystallize. When the trajectory is measured and the orbit is calculated, and we know definitively whether 3i Atlas stayed or left. If it left, this becomes academic. A case study, lessons learned about information management during scientific uncertainty. If it stayed, then we're in uncharted territory. Then every choice about what to reveal and when carries enormous weight. Then the cost of knowing becomes real and immediate and unavoidable. Are we ready for that? As a species, as a civilization, as a collection of governments and institutions that can barely coordinate on terrestrial challenges? Probably not. But ready or not, December is coming.
Now we approach the moment everything hinges upon, the reacquisition, the reemergence. The return to visibility after 8 days of solar blindness. Early December 2025. Approximately December 4th or 5th, depending on 3i Atlas's exact position and velocity. That's when the object will be far enough from the sun's glare, more than 30 degrees of angular separation, to become observable again. The preparations have been underway for weeks. Observatory directors coordinating schedules, ensuring their facilities are available during the critical reacquisition window. Amateur astronomers calibrating equipment, checking alignment, preparing data, processing workflows. Online communities
organizing observation campaigns, planning to share data in real time across forums and social media platforms. Everyone knows what's at stake. Everyone understands that the next few days will answer questions that have been accumulating since July. Ground-based observatories in the southern hemisphere will have first view, pre-dawn skies. The eastern horizon still dark, the sun not yet risen but beginning to lighten the sky. Telescopes pointed toward the expected coordinates where 3i Atlas should emerge from the solar glare, waiting for the interstellar visitor to reappear. CCD cameras will capture the first images, long exposures stacking photons one by one, building signal above noise. Computer algorithms will analyze each frame, searching for motion against the fixed stars. And somewhere in that data, in one of those early frames, 3i Atlas will materialize. A faint dot moving slightly from one exposure to the next, proof that it survived perihelion, confirmation that it still exists. Within hours of first detection, observations will be shared across the international astronomical community through the Central Bureau for Astronomical Telegrams, through email networks, through informal channels connecting observers worldwide. The Minor Planet Center will collect data from multiple sources: professional observatories in Chile and Australia, amateur astronomers in New Zealand and South Africa, space-based telescopes unaffected by daylight. And they'll begin calculating preliminary orbital elements, the mathematics of position and motion, the geometry that will tell us everything we need to know. This is where we'll get our answer, not speculation, not interpretation, just mathematics. The orbit either is or isn't bound. The eccentricity, the measure of how elliptical or hyperbolic a trajectory is, will be calculated from multiple positional measurements. If eccentricity is greater than 1, the orbit remains hyperbolic. 3i Atlas is still on an escape trajectory, still leaving the solar system. Natural comet confirmed. If eccentricity is less than 1, the orbit has become elliptical, bound, captured, meaning a maneuver occurred at perihelion, meaning something changed during those 8 days behind the sun. The determination will be clear within 24 hours of reacquisition. The math is straightforward. The orbit either is or isn't bound. There's no ambiguity once you have enough positional data points. And at that moment, everything changes or everything stays the same. Scenario A, orbit still hyperbolic. 3i Atlas continues outbound. The anomalies remain unexplained but unthreatening. The chemical peculiarities become interesting footnotes in astronomy papers. The trajectory coincidences get filed under rare but natural. The missing Mars data eventually gets released, with disappointing explanations, equipment limitations, processing delays, nothing unusual captured. We return to our comfortable assumption that the universe contains mysteries, but no immediate threats. That interstellar objects are cosmic debris, not reconnaissance probes. That we're alone until proven otherwise. And we wait for the next visitor, knowing Vera Rubin Observatory will find them regularly now, one every few months once it's operating at full capacity, dozens cataloged within the next decade, larger sample sizes providing better statistics about what's normal and what's anomalous. Maybe one of them eventually will be unambiguously artificial. But 3i Atlas won't be that one. Scenario B, orbit now elliptical. Eccentricity below 1. Trajectory captured, maneuver confirmed. This is the scenario that changes everything, because objects don't naturally break from interstellar velocity and capture themselves into solar orbits. The physics doesn't work that way. To transition from hyperbolic to elliptical requires velocity reduction, and velocity reduction requires thrust. Either you hit something which would be catastrophically obvious, or you fire engines. Natural capture scenarios exist, but require extremely specific conditions. Aerodynamic braking, through stellar atmosphere, three-body interactions with perfect geometry, exotic gravitational assists we've never observed. All technically possible but extraordinarily unlikely. Deliberate propulsion becomes the simpler explanation. And if deliberate propulsion occurred, then 3i Atlas is technological, not a comet, not natural debris, something sent, something designed, something that chose to stay. At that point, NASA will call an emergency press conference. Not immediately, they'll want time to verify data run models, understand implications, but within days, because too many independent observers will have the same data.
The orbital calculation will be confirmed by amateur astronomers' universities, international space agencies. Attempting to suppress or delay would be pointless and counterproductive. The announcement will be carefully worded, continued analysis required. Doesn't necessarily imply artificial origin. Unusual but not unprecedented orbital capture. Emphasis on scientific caution. Acknowledgement that natural explanations exist and must be fully explored before jumping to extraordinary conclusions. But the subtext will be clear. Something unprecedented has occurred. An interstellar object has chosen to stay in our solar system. The implications deserve serious attention. Radio telescopes will be deployed immediately. The Very Large Array, Green Bank, FAST in China. Every major facility will turn toward 3i Atlas and listen across all frequencies. If there's transmission, any signal, any evidence of communication capability, we'll detect it. And if we do detect a signal, then SETI protocols activate. Then the post-detection frameworks get tested for real. Then we face questions about verification, international notification response decisions, questions we've theorized about for decades, but never actually confronted. Who speaks for humanity? Who decides whether we respond? What do we say? How do we avoid triggering hostile reaction? If intentions are unclear, there are protocols. The 1989 SETI guidelines revised 2010, but they're aspirational, not binding. They assume rational actors cooperating in good faith. They don't account for competing national interests, private organizations claiming first contact rights, public demand for immediate answers. Reality will be messier than protocols anticipate. Multiple actors pursuing different goals. Disagreement about interpretation. Confusion about authority. The first few weeks will be chaotic, not violent necessarily, not dangerous, just disorganized. Humanity fumbling toward response without clear coordination. Eventually, frameworks will emerge. The UN will convene. Scientific organizations will issue position papers. Governments will stake out positions. And gradually, a new normal establishes itself. One that includes the reality of non-human intelligence existing in our solar system. One that accepts we're not alone. If that's what December brings, then everything after will be divided into before and after. The moment when certainty replaced speculation, when wondering became knowing. But that transformation won't be instantaneous or dramatic. No invasion fleets, no first contact protocols, no dramatic announcements reshaping civilization overnight. Change will be gradual, unfolding over weeks and months as we study the object attempt communication watch for any indication of what it intends to do next. The darkness won't lift all at once. We'll still be working with incomplete information, making decisions based on insufficient data, fumbling toward understanding without clear roadmap, but we'll know something fundamental has shifted, that we're no longer alone in the solar system, that something from beyond is here. And that knowledge, that certainty, will gradually permeate every aspect of how we think about ourselves and our future. 3 weeks. Perhaps less. Until we know. Until December brings answers. Until the trajectory is measured and the orbit is calculated and speculation becomes certainty. The countdown continues. There's a photograph I keep returning to. Not from NASA, not from ESA, not from any institutional source with billion-dollar telescopes and professional astronomers analyzing every pixel. It's from an amateur observer in Australia. Early October, a backyard telescope, 8 inches of aperture, nothing special, the kind of instrument thousands of enthusiasts own.
Long exposure showing 3i Atlas as a small, slightly elongated smudge moving against the background stars. The image isn't perfect. There's noise in the background, the grainy texture of a sensor pushed to its limits. The stars aren't perfectly round, slight, trailing from imperfect tracking, the inevitable compromise of amateur equipment. The comet itself is barely distinguishable from faint background galaxies, requiring careful study to identify which smudge is the interstellar visitor and which are islands of stars billions of light years away. Nothing dramatic, nothing revealing secrets or proving theories, just a simple image showing that the object exists, that it's real, that it's out there, moving through space regardless of what we think about it or hope it might be. But there's something profound in that simplicity, something that professional images, with their perfect calibration and institutional backing, somehow miss. This is one human standing in their backyard, pointing a telescope at the sky because they wanted to see for themselves. Not waiting for official announcements, not relying on others to tell them what's real. Just looking up and paying attention, that photograph represents something important. It shows that some questions aren't about institutional authority or official announcements or who has access to the best equipment. Some questions are about looking up and paying attention and acknowledging that the universe is under no obligation to conform to our expectations. The cosmos doesn't wait for our readiness. It doesn't ask permission before presenting us with mysteries that challenge comfortable assumptions. It simply is vast and strange, and indifferent to whether we're prepared for what we might discover. 3i Atlas exists. It came from somewhere else. It's moving through our solar system right now, following a path determined by gravity, and possibly by intention we can't yet confirm. That's verifiable, observable, true, regardless of interpretation or speculation. What it means, what it tells us about our place in the cosmos, about whether we're alone, about what intelligence does when it spans the distances between stars, those questions remain open. December will close some of them, will give us data that constrains possibility and eliminates some hypotheses while supporting others. But December won't answer everything, can't answer everything. Because even if we determine that 3i Atlas is technological, we won't immediately understand its purpose, won't predict its behavior, won't know what its presence means for humanity's future. We'll just know that it's there, that we share space with intelligence we didn't create, and then the real work begins. Not the speculation we've been doing for months, but actual engagement, communication attempts, careful observation, the slow process of understanding something fundamentally different from ourselves. That work will take time, years, decades possibly. It won't happen through dramatic revelations or sudden breakthroughs. It will happen through patient attention, repeated observation, gradual accumulation of data points that eventually coalesce into understanding. This is how first contact actually looks, if it happens at all. Not Hollywood spacecraft landing on White House lawns, but slow recognition. Increasing certainty, careful attempts at engagement with something that doesn't share our biology, our culture, our communication frameworks. It's messy, uncertain, frustrating for those wanting clear answers immediately, but it's also real. Happening now, potentially. And that makes it more significant than any fictional scenario, no matter how dramatically satisfying those scenarios might be. So we watch, we measure, we calculate, we attempt understanding using the tools we have while acknowledging their limitations. And we wait for December, because December brings the data, the trajectory calculations, the orbital elements that will tell us whether 3i Atlas stayed or left, whether this story continues or concludes, whether we're alone or accompanied. The view from here, late November 2025, standing on Earth, looking out at a solar system that might contain intelligence beyond our own, is strange and uncertain and pregnant with possibility. We don't know what comes next, can't predict how this ends, don't have frameworks adequate for the scenarios we're considering, but we're looking, we're paying attention. We're ready to adjust our understanding when new data arrives, and that might be the most human thing of all. The willingness to confront uncertainty without retreating into comfortable denial. The curiosity that drives us to keep watching, even when answers remain elusive. The recognition that some questions are worth asking, even when we're not sure we want to know the answers. 3i Atlas is still out there, moving through space, following its trajectory toward whatever comes next. We're still here, watching, wondering, waiting, and in a few days we'll know. If one day our own machines drift beyond our sun, may they look back as 3i Atlas did not searching for home but for the meaning of having left. What will they find? What will be watching them? And when they signal back across the void, who will we have become in the time it takes their message to arrive? The universe doesn't owe us answers, only wonder, and wonder is enough. For now we wait. December is coming,